In this lesson we will be looking at volume, and to start the lesson I want to do a little bit of a review. And so the first thing that we're going to start with is a figure. I like to draw things, and so I'm going to go ahead and put an image right here. And so I've got what most of you hopefully recognize as a rectangle. And so let's give it some units, because I want to make sure that you understand we need to have these units, because really if we just have a 3 here, it really doesn't mean a lot to us. So let's make it 3 meters. And here I want to make this 5 meters. Now the first thing that I want to talk about is the perimeter. Okay, so we'll talk about perimeter first. And with perimeter, hopefully you remember that perimeter is the rim, right? Perimeter is the rim, and so it's the edge, it's around, it's kind of the outside, and I'm going to trace around this perimeter, right? Now what I want you to see is that we can find the perimeter a couple of ways. One of the ways is we can take this 5 meters that's here, and we can assume that this is 5 meters if this is a regular shape. We can also assume that this left side is 3 meters. So I could easily take 5 meters plus 3 meters plus 5 meters plus 3 meters, and I could solve and find that it is 16 meters. Now another way we could look at this is perimeter is really equivalent to 2 times length plus 2 times width, and that equals your perimeter, right? And so I could take 2 times 5 meters plus 2 times 3 meters, and I would be able to still solve and get 10 meters plus 6 meters equals 16 meters. Now that's perimeter. Now the next thing I want to look at is the area. So in the area we need to define and maybe use some of the words that you would hear when a problem is describing area. Maybe it would be something like the covering of a certain area. Maybe they would just say area. Maybe they would say, square meters. They're giving you some clue that this entire area in here is going to be used. Now when you look at this, and I'm going to back this up a little bit and draw a different picture. You look at this, and this is something I described in an earlier video. I want to show you this. Let's break this into 1, 2, 3, 4. 1, 2, 3, 4. That's not very good. Let's space those out a little bit better. Okay, let me back this up. 1, 2, 3, 4. So there's 1, 2, 3, 4, 5 meters across. We can do the same thing for the 3. 1, 2, 3. I'm going to do that on this side too. Alright, I think you see the pattern. Now I want to go ahead and connect these so you can kind of see what we're talking about. So I'm going to pull this down here, pull this down here, right? So we kind of make it look like a small football field. Each one of these is 1 meter long. And so now I'm going to pull this across and this across. Each one of these is 1 meter long. So this area right here is 1 meter by 1 meter, which is equivalent to, draw that same little area right there. It's equivalent to 1 square meter. Or I could say 1 meter squared. Either way, it's the same answer. And so you could look at the area by just simply counting the squares. And so get a different color here, and I could say, hey, here's 1, there's 2, there's 3, there's 4, there's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So it would be 15 square meters, or meters squared. It's the same thing. Now another way of finding area is really just using the formula, and that's probably the easiest way. Area is equal to length times width. So I take that initial length right here and that width, and I'm going to go back over here and I'm just going to say, hey, that is 5 meters times 3 meters. That equals 15 square meters. Now the reason I wanted to talk about perimeter and area is because I want to now move into volume. And when we talk about volume, hopefully when I say volume, you want to maybe conjure up this idea of how much something can hold. Maybe you use the word capacity, but we're looking at really a three-dimensional object. We're looking at not only the length, not only the width, but we're also going to be looking at the height. And so if I take this original drawing, and let me go ahead and see if I can kind of duplicate that here, and I say that it's still 3 meters by 5 meters, I have to then go ahead and add another dimension to this object. And so now I'm going to add length and width, and possibly we'll describe it as height, right? So I'm going to put in this extra shape here. And so if we were looking at this and I said, hey, this is 3 meters, this is 5 meters, and let's say this measurement is 2 meters. Now I have 3 different measurements. Now, much like area, volume also has a formula. And that formula is length times width times height. But one way that you can look at it before we look at the formula is we could again measure off these different meters, right? And so now I have 1, 2, 3, 4, 5. And I know it's not super straight, but just kind of bear with me and maybe we can make the best of this. So that kind of looks similar to the object up top. But now I've got to kind of make it go back this way, correct? And then I have to do this up here. The one thing, this is 2 meters. That means that if I want this 1 meter measurements, I also have to include this. And hopefully, even with this poor drawing, you can see that I've got that initial area that we talked about, right? The 5 by 3. I still have that same area. It still is this spot that I'm talking about right in here. But now, instead of just having the 5 by 3 that you can see as I kind of work through these blocks, right? That's still part of this same block, so that counts here too, right? So I've got this 5 by 3, which equals 15 meters squared. I also have this entire other set of blocks that are in the back, right? And if you could envision flipping that and seeing the face of this other one, I think you'd kind of see it's like, hey, I doubled it. And I doubled it because it is 2 meters thick. So I could count each one of these blocks. I've got 15 on the front. I have 15 on the back because there's some that I can't see. So I would be able to come up with that it is 30 meters cubed, right? 30 meters cubed, or meters cubed, like that means the same thing. Now you can look at our original formula, length times width times height, and I could take volume is equal to 3 times 2 times 5 meters. 3 times 2 times 5, all of those are meters, should have wrote that in, and that would equal 30 meters cubed, or meters cubed.